everyone, and welcome back for another awesome episode of Damos in the Class. Today's aim will be using models to add mixed numbers with unlike denominators. This is going to be our benchmark review. All right, so our first problem, what is the sum? So we have our whole and we have our fractions. So the first thing we want to do with these diagrams is we want to transfer these diagrams into actual numbers so we can understand what exactly we're looking at. But first we want to know what the sum means. That means we're going to add. All right, so we're going to add these two diagrams, which will translate into actual numbers. So that's the first thing we're going to do. So looking at this represents one whole. So that means we have a whole number 1. Then we have 2 1/4. So if we add that together, that would just give us 2/4. So this diagram equals 1 and 2/4. The same thing, we're going to look at this bottom one. We have 2 whole pieces. So that's going to give us a whole number of 2. Then we're going to see we have 3 fraction pieces, and they're 1/8. And we have 3 of them, so that's going to give us 3/8. Easy enough, right? So that's the first thing we want to do, step 1. Now that we have that, the problem asks us to find the sum, which means we're going to add. So we're going to make this an actual problem. So we're just going to draw our equal sign, and we're going to add our operation sign. So now, we've already learned that when we have fractions, because when we deal with mixed numbers, that's what this is. A mixed number is a whole number with a fraction. Just go ahead and write that here. And that's a whole number with a fraction. All right? And so we have our whole numbers here and our fractions here. So when we have these type of problems, we are to deal with the fraction side first. So our rules for fractions is when we are adding and subtracting, we must have the same what?
The bottom number, denominator.
Exactly. The bottom number is called the denominator. They both must be the same. They are not the same, so therefore we need to change them to the same denominator. And everyone knows that we can get 4 can turn into 8 if we multiply that by 2. So that's what we're doing. We're going to change our denominators to 8. So we're going to set that at an 8 for both of them. And then what did it take for us to get from 8 to 8? What did we multiply by, Johnny?
Times 1.
Yep, times 1. And we know if we do it to the bottom, then what we got to do?
To the top.
Exactly. We got to do it to the top. Great job. So now that's 3 times 1, and that's going to give us what?
3.
Exactly. All right, so we're going to do the same thing to the top. So from 4 times what? What did it take to get to 8?
Times 2.
That's right. So times 2 got us to 8. And so when we do it to the bottom, we said we got to do it to the top. So 2 times 2 is what?
4.
Great job. So now we done created our fractions, and they both have the same denominator. And once that occurs, we can go ahead and use the operation of addition and add. So that's what we're going to do. And the first thing we do is, since we have the same denominators, I like to go ahead and set my answer for what? The denominator that we have, which is the 8 that we just got to. So that's already there. And now, if you've been watching my videos, all we need to do is circle our numerator, which is our top number. And that number sentence says
4 plus 3.
Exactly. And how much is that?
7.
Exactly. Good job. So now we have a fraction of 7/8. Let me write that a little better, guys and gals. All right. So we have a fraction of 7/8. We are now done with our fraction side. Now, all we need to do is move over to our whole number side, and we could just add them as normal. So 1 plus 2 is how much, Amir?
3.
Exactly. So now we get an answer of 3 7/8. Great job. first problem, what is the sum again? So, we are trying to practice for the benchmark in math, and these type of problems will definitely be ones that they like to use, which have a lot of symbols and pictures and diagrams that needs to be translated in order to understand the problem and be able to execute to get the answer right. So we are practicing on that, making sure we are building his skills and sharing all of the techniques and tricks and tips and tools to help you also be successful. So these are hexagons. And how do we know? Because they have 6. Oh, and also I hand drew these, so please bear with me. So yeah, but a hexagon has 6 sides. And that is what you want to focus on. And geometry will be, they will expect you to know certain things like hexagon, pentagon, and so forth. So hexagon is 6 sides. Pentagon is 5. So we have 6 sides, meaning 6 angles. So let me write that better. So I don't want anyone to get misinterpreted. So we have 1, 2, 3, 4, 5, and 6. Okay, and that's what we need to know about a hexagon. And with that being said, I'm just going to remove the sides and put angles because that's what they really are. So with that being said, again, these let you know that we have one whole. So when reading to make the numbers, that makes it easiest for us to understand. So this is, how many holes do we have here, Jamir?
1 hole.
How many altogether?
1, 2, 3, 4.
So we have 4 holes, which means we have a whole number of 4. So that's the first thing we're going to do to start to write our problem into numbers. Now, this is a fraction part. So now you need to understand what you're looking at. So we are looking at, if you take a closer look, these diamond shapes, and I was drawing, so it's not the best. But if you slice them in half, both this way, then you can see that you actually have 4 triangles. And that's what you want to picture, because within a hexagon, there are 6 angles, okay? So we have now 4. So our total is 6, correct? So that's what's going to be our denominator. So our denominator is 6 because a hexagon has 6 angles. Now that we looked at this and we've counted how many?
4 of them.
4. We have 4 triangles. That's what's going to be our numerator. So this diagram translates into 4 and 4 over 6. So now we're going to look at the second diagram. We only have 1 hexagon. So that's clear to see that that's going to equal 1 whole. And this second diagram, which is a fraction, it was drawn a lot more simpler than the first one to trick you. So always remember, when you see diamonds, diamond shapes are just 2 triangles together. Okay? So that's how we got 4, because those were 2 diamond shapes. But this one here was already depicted for you to see that they were how many triangles?
4.
Right, 4 triangles. So again, hexagon is 6 angles, so that gives us our 6, and that also gives us our 4 for the fraction part of the diagram. Right, and so, like the problem says, we are adding. So we're going to go in and we're going to add our equal line. We're going to add our operation sign of a plus. And because we already have, the denominators are already set at the same, they both are 6, then we could just go ahead and put our denominator at a 6. And like we know already, then we go in and circle our numerator, and that gives us our number sentence. And what is our number sentence?
4 plus 4.
And 4 plus 4 is how much?
8.
There we go. Great job. Do you notice something when you put an 8 over top the 6?
Improper fraction.
There we go. Bling, 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 bling. I'm going to put IF. And if you know, you know. But if you don't know, I'm going to do you one better. And I'm going to write improper fraction. Oops. That's what the IF stands for. All right, so when you see me put that, you already know. So that's correct. 8 over 6 becomes an improper fraction. So what do we do with that?
Divide.
We divide. So therefore, we're going to just put this 8 right into our division. We know what IF means since I wrote it over there, so I'm going to use this space. And how many groups of 6 can we get out of 8? And before you say anything, as a rule of thumb, just ask yourself, what is 6 times 2?
12.
And that's too big. So you already should know then that you only can get 1 group. There we go. And that's how you do with all numbers. Anytime you're facing with dividing, the number on the outside house, the first thing you say, times 2. Where does that get me? Too big? I only could do 1. That's correct. So now we do the multiplication. 1 times 6 is how much?
6.
All right. Then we do our subtraction. And 8 take away 6. We're at 6. We count up to 8.
1. It equals 2.
Exactly. 2. All right. So we have now a fraction of 2 over 6. But like I teach you, and math has taught me, that if you end up with 2 even numbers, you can always get you at least another group of 2. And we have 2, so we could definitely get a group of 2 out of 6. We can actually get 1 group left when we divide by 2, because we're going to divide by 2. We're going to divide by 2. Then that's going to leave us with 1 over 3. I don't have a lot of room, but it's 1 over 3. So we did 2 divided by 2, left us with 1, and 6 divided by 2 left us with 3. So now we have a fraction of 1/3 is our new fraction, which I'm going to move the answer over here. So 1 over 3 is our fraction. But you see this? We got our whole number 1 right here, right? So we're going to add that whole number to our whole numbers. We're just going to put that right over top of the 4. And so now that we finished everything on the fraction side, we can go ahead and just add our whole number side. So now we're going to add 4 plus 1 is what?
5.
And then 5 plus 1 is?
2.
Is 6?
6.
Good job. So now we have an answer of 6 1/3. That is the answer. All right, so for our next problem, again, diagrams. So we have circles this time, and our circles are letting us see which ones we have holes. So how many holes do we have in this side?
3 of them.
Right, so our whole number for that side is going to be a 3. So let's go ahead and write in our 3. Well, I'm going to write it over here, though. All right, and then so now we have another circle, and it's not fully whole. It's our fraction side. So first thing we need to do is see how many parts is this circle broke up into, so we can understand what our denominator is going to be because it's a fraction. So we can start from here. 1, 2, 3, 4, 5, 6. We have 6 total parts, so that is what our denominator is. And then for fractions, fractions means the top number, the bottom number, which is the denominator, means total parts. And I'm sure you guys know this if you watch my video, but I'm just going to let you know in case this is your first time. So we have total parts at the bottom, and our top number is going to represent our shaded parts. So how many parts do we have shaded, Job Man?
4.
Yep, we got 4 parts shaded. So our fraction and our mixed number, remember, a whole number with a fraction is a mixed number. And so we have 3 and 4 6. That is what this first diagram translates into. And so now we're going to do the same thing. Oops, I'm sorry, guys. I need to adjust to these pieces for this problem. I apologize. Like I said, I draw them myself, so bear with me. All right, so now how many holes do we have on this side?
2 of them.
Exactly. So we have a whole number of 2. So we're just going to write that down. And then we're going to look at our next circle. And the first thing, like the top one, we have to decide how many total parts do we have is what's going to be our bottom number. So we're going to do the same thing. We're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 parts here. All right. And again, the top number, which is our numerator, is going to be the shaded. And how many shaded? 1, 2. So we have 2 parts shaded. So that is going to be a 2 over 12. So now this diagram represents 2 and 2/12. So for us to add, we're going to do the same thing. We're going to add our equal line. Then we're going to put in our operation. But then we're also going to look and we're going to notice that we do not have what?
The same denominator.
Exactly. We don't have the same denominators. And without the same denominators, guys, we can't do anything. Not in subtraction or in addition. When we get to multiplication and division, that's different. So move that over so I can have just a little bit more room. All right, guys. So what do we know about 6 and 12? Can 6 become 12?
Yes.
How can it become 12? What do you have to do for 6 to become 12?
We have to divide.
If you divide, it's going to make it smaller. We want to make it bigger. 12 is bigger. So what do we have to do for 6 to become 12?
We have to choose.
We don't have to choose anything. You have to know your multiplication. That's all I'm asking.
6 times 2.
That's the only way. There's no other answer. There's no other way. And again, when we're doing division, you must think multiplication. That's the only thing. That's the only way. So we're going to change our denominator to 12. Because we have to get the same denominator or we cannot move forward with the problem. And if you try to move forward, it's just wrong. So if you want to get it right, then you must understand that they have to have the same denominator. So therefore, you must understand that you have to figure out how to get that and what that denominator should be. And when they have like multiples, because 6 times 2 is 12, then that's where we go to the 12, because 12 cannot become 6, only if you're dividing. But we're not dividing because 6 will never be able to be, 6 can only become 12. 12 can't go down to be 6 when you're looking at multiplication. And so that's what we're looking at when we're doing fractions, because that sign here means divide. So when we're looking for the answers, we must look into the opposite, which is multiplication. So 6 times 2 gave us 12. 4 times 2 gives us what?
Equals 8.
Exactly. And then times 1 from 12 to stay at 12. So we times 1 for the 2 and we'll stay at 2. So now we have same denominators, so we can go ahead and now add. So that's what we're going to do. We're going to write our denominator of 12 that we just came with. We're going to circle our numerator, which gives us our number sentence of 8 plus 2, which is how much?
10.
Exactly. So now we have our answer of 10 over 12. Okay? And for this purpose here, we're not going to leave it at 10, 12 because I never do. Whether the teacher asks you or not, in math, defines you to do so, which is leave them in the simplest form possible. All right? So the simplest form possible just means we have to break this down to the smallest form or groups that we can take out that they have in common. So we had 10 over 12. I'm just moving it over so I can have a little bit of room. And I'm going to tell you the rule of thumb is if you have two even numbers, right? And what are my even numbers? Do you remember, Jamia? 0,
0,
2. Come on, let me hear you.
4,
Mm-hmm.
3, 6, and 8.
That's it. Those are all the even numbers. So as you see, there's a 0, and we don't look out our 10s. We only look in the 1s. You see there's a 0, you see there's a 2. That makes them even. All right? So anytime we have an even number, means we can also divide by 2. And that is what you are to do. When you hit two even numbers on top of each other in a fraction, immediately divide by 2. 10 divided by 2 is going to give me 5. Why? Because 5 times 2, remember, it's always the opposite. 5 times 2 will give you the 10. That's why that's the answer in division. 12 divided by 2 is going to give you 6. Why? Because 6 times 2 will give you 12. That's why. That's why you always have to think opposite when you're doing division or multiplication. Whichever one you're doing, you must think about the other one in order to get the answer. So now we have a new fraction of 5 over 6. We can't get no more 2 groups. Why? Because 5 is not an even number. 5 is odd. We have to have 2 even numbers in order to get another 2 group, at least a 2 group. You might could even get bigger within the even numbers. It could even be a 2, it could be a 4, it could be a 6, it could be an 8. But it will only be those numbers when it's 2 even numbers. If those numbers share a 4, a 6, or an 8. But if they don't share nothing else, they definitely will share a 2. That's why you must always at least divide by 2. All right, so now that we have our fraction down to the simplest form, we can go ahead and now add our whole number side. And we just have 3 plus 2, and how much is that?
5.
Exactly, 5. So the answer is 5 and 5 over 6. Right, so for our next problem, again, what is the sum? So we have another set of diagrams. Okay, so now we have this square that's representing a hole. And how many holes do we have?
1.
All right, so we're just going to write out number 1. Now, our next square is split up into tenths. As you see, there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that means our denominator is going to have a 10. Okay, because that's how many parts that is split up into. So that's the first thing you need to understand. Secondly, remember denominator is total parts. Total parts are 10. But how many is shaded is for our top number numerator. So how many shaded? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 shaded. So that means that fraction over there, this diagram, equals this mixed number, of 1 and 8 over 10. All right? So for our second diagram, we have 2 whole numbers. That's just going to give us our 2. And our second part, which is the fraction part, which this square is split up differently. The first one was split up into tenths. This one is split up into what? Hundreds. Exactly. So our denominator has to be 100 then. And I'm just going to already move over because I'm going to need room. So let me move over, guys. 1, 8 over 10. And 2, we know it's 100 so far. And we're going to do the same thing. 100 is how many total parts. And now we need to figure out how many shaded. So we look at the bottom. We have 1, 2, 3. But those whole row is filled. So even though it's split up into ones, because each one of ones, each row still equals 10. like over here, 1 whole 10. So 3 rows filled up with every little one is still 3 10s. And we know if we count by 10s, we'll have 10, 20, and 30. Yes? Yes. So 30, but then we have 2 1s up there. So that's going to give us a total of 32. So that's going to make this fraction 32 over 100. And so, like the problem says, we need to add. But can we add? Can we add these fractions?
No.
All right. Why not?
They don't have the same denominator.
Exactly. So we need to set them at the same. But it's safe to say we know 100 is not going to become 10 because we have to multiply to get the answer. And multiply means go higher. So only number that can go higher would be the 10. And if 10 can we make 10 100 using multiplication? Yes, we can. So therefore, we're going to use 100 as our denominator. And so we're at 100. So what did we do to stay at 100? We didn't do anything. We just multiplied by 1. And the same thing like 32, because what we do to the denominator, we must do to the numerator. We multiply that times 1. And 32 times 1 is how much, Jamia?
32.
Exactly, 32. And so we're going to move up to the top fraction. And we know 10, we're going to need to figure out 10 times what will get us to 100. Well, I'm going to say 10 times 10. So we're going to do times 10. We have 1 times 1 is how much? 1 times 1 is how much?
1.
Exactly. And how many zeros do we have?
2.
Remember that? They go to 2 zeros. So in case you was not sure, that lets you know that you're right. So 10 times 10 equals 100. What we do to the denominator, we must do to the numerator. So now we do 8 times 10. And then how much is that?
80.
There we go. Great job. So now we have 80. So now that we both have the same denominators, we can go ahead and do what the problem asks is find. All right. So now that we have our denominators, let's go ahead and get the sum. So we're just going to bring over our equal line, and we're going to add in our operation sign. And now we know we have our denominator is 100, so we're just going to put in our 100. Going to move over in case we end up in having to reduce. And so we see we have that, so we can go ahead and we can circle our numerator. So for double digits, guys, I would advise you to write it separately. So find your space, Jamie, on the side, and you're going to write 80. First, let me make it look like 8. 80. Sorry, guys. 80, and then 3, and then 2. So make sure you line them up, guys, right. With the 2 underneath the 0 in the 1's place, and the 3 underneath the 8 in the 10's place. Very important, right? So now we know 2 plus nothing leaves us at the 2. Yes? And we at 8. We're going to count up 3 times.
2.
9, we're at 8.
10. 11.
We're at 8.
9, 10, 11.
That's where we at. That's where it stops. 11, which gives us an answer of 112. Over top of 100. Again, 2 and 0. Those are our even numbers. Remember, we said 0, 2, 4, 6, and 8. Even numbers, yes?
Yes.
So we must and we will divide. So we're going to at least divide by, I'm going to divide by 2, guys. So, divide by 2 and divide by 2. And since that might not be easy, and it shouldn't be that hard either, but I'm going to replace our addition. So I can then put 1, 1, 2 in the house with 2 on the side. That's what we're doing. We're doing that, and we're going to do that with 100. But first, let's do it with the 112. So we know that 2 is too big to go into 1 by itself, but 2 can go into 10. So we're going to think 2 times 2 is 4.
2 times 5.
See, there you go. Okay, mister. 2 times 5 gets us to 10. That gets us as close as we can get. So we're going to do that multiplication. 5 times 2 is 10. 11, take away 10 is going to leave 1. We're going to bring down that last 2. Yes?
Mm-hmm.
And then we're going to have a 12. Now we're thinking the same thing. How many 2 groups can we get out of 12? So
Times 6.
there we go. See? So you take multiplication. 2 times 6. Great job. I'm proud of you. Is 12. So we do that multiplication, and 12 take away gives us 0. So we have an answer on top, numerator of 56. So now, there's 2 ways you can look at this. Either you already know that half of 100 is 50, or we can go ahead and do the division. Well, I want to show you both, so I'm going to show you the division. So we got the 100. We're going to divide that by 2. And like you just told us last time, because we know 2 is too big to go into 1 by itself, but it can go into 10, right?
Mm-hmm.
So 2 times what gets you 10?
Times 5.
There we go. And 5 times 2 gives you the 10. Take away. We don't write the 0 from the 10 take away 10. We do bring down this last 0. But when you have 0, you can't get nothing out of it. So the answer is only 0. And then 0 times 2 is 0, which leaves us with nothing. So the answer would be 50. So now, that is our new fraction. Yes? Yes. But does anyone else besides me see a situation?
Improper fraction.
There we go. Boom, 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 boom. Go ahead, John, man. You are on it. That is a great job. Improper fraction. IF. So, Jamir, you are so correct. So, we are going to go ahead and put this 56 in the house. So, I'm going to move this out the way. And I'm going to put my 56 in the house. And I'm going to put my 50 on the outside. But we already know. We got 50. We have 56. We only could get one of those because we already know that 50 times 2 is 100. So we ain't going to do times 2. But like I told you, if you was even worrying, just say in your head, 50 times 2. That's 100. Way too far. So we know we only can get one group. So we do the multiplication. 1 times 50 is 50 with a 6. And now our new fraction is 1 and 6 over 50. Okay? Yes?
Yeah.
All right. So now, what we're going to do is we are going to take that whole number, right?
Mm-hmm.
And add that right over top. Because it is a whole number. It has to leave from the fraction side. It go with the whole numbers. So now we have to add the whole number side. We have 1 plus 1, which gives us 2. Yes?
Mm-hmm.
And then we have 2 plus 2 is 4. That would give us an answer of 4 and 6 over 50. Now, 6 and 0, even numbers, means we can get a 2 group. So we divide by 2, we actually get 25 and 3. So 4 and 3 25s would really be the answer. 4 and 3 25ths is the real answer. But it just depends on what you want. Now looking back at what they wanted, but yeah, so that's the answer. So, I want to show you my way that I'm showing you and have showed you is the absolute correct answer. What I will say the difference is with school today, they're not getting down to the nitty gritty of the 4 and 3 25ths. They are stopping and not reducing it small and things of that nature. I am making sure I show my son the full totality. So I'm going to show you what the school probably would assign and won't take it as far. But when you're learning something, I don't understand why you need to learn half of it. So I teach all of it. So let me just show you the side that I'm sure that the school or a test, you might see that answer first and felt like you didn't see this answer. So I want to take it back to the step right here where we when we added 80 and 30 and we got 112, which is correct, over 100. Now, I went ahead and divided by 2 because I wanted to show you that, of course, when it's even, we need to simplify, reduce, right? Get more groups out, as many groups as we can, leaving it in its simplest form, which is 56 over 50, which reduced it to 1 and 6 over 50, which then turned into 4 and 3/25 in total. That is still the definite smallest way, the simplest way to show the answer. However, 112 over 100, instead of stopping there or going there and doing what I did and dividing by 2, another correct way could be this is automatically an IF, right? Improper fraction. So what we would do with that is we would take the 112, we would put that inside of our house with our hundreds on the outside. And knowing that we already have 100, if we say times 2 with 100, that's already 200, which is way too far. We only can get one group of 100. So we put that 100 underneath the 112, leaving us with 12. Leaving us with 12 over 100, taking the same one, adding it in, giving us then 4, because that 1 we added, 1 plus 1 made 2. 2 plus 2 made 4. That's how we got our 4, leaving us at 12 over 100. Now, for the purposes of the work that I'm doing with my son, this is what the school is looking for, okay? And I have a few issues with leaving it like that because, again, the rules of math, even we have a 2, we have a 0, which means we still need to divide. So this is the answer for purposes that he needs to put into his homework. And if you see it on the test, then go with that because that is the answer. However, I am going to show you that these are the same exact, but this is just the simplest way to show that. So we have 4 and 12 over 100. We're going to divide again by 2, denominator and numerator, which is going to then give us 6 over 50, like we had when we were here. And then from there, still 6 and 0 are still our evens, so we still can get another 2 group. If we can't get nothing else, we know we can get a 2 group. So we divide again by 2 and by 2. 6 divided by 2 will give us 3. I don't want to put it up here where you can't understand. 6 divided by 2 will give you 3, and 50 divided by 2 will give you 25, and you keep the 4. So all of this is the answer. But again, like I say, it depends on who's asking for the answer and how in-depth of answer they're looking for. But as far as I'm concerned, me and math wants the simplest, the most precise, the most accurate. So to be on the safe side, and when I work any test or anything, I show you everything. And that's just that. And then you can take whichever one you want, or when I look at the choices, whichever one y'all had up there, there it is. And there it is. Next problem. Again, we have another diagram, which shows us how many holes?
1 hole.
All right, so then we have a 1. And how many fraction pieces do we have?
6.
How many?
1, 2, 3, 4, 5.
5. So our fraction is 1 and 5 over 6. All right, and so how many whole pieces do we have here?
1 whole.
And how many fractions?
1, 2, 3, 4, 5.
5, how many?
5
12ths.
drops.
Yes. Okay. So looking at that, what can we see that we have with these fractions? Do they have the same or don't they? 1 and 5 over 6 and 1 and 5 over 12. Do they have the same denominator?
No.
All right. So what we're going to have to do?
Make them the same.
Exactly. And it's 12 and 6. So how do we do that?
6 times 2.
So what's the denominator going to be?
The 12.
Thank you. Good job. The 12. Yes, and doing 6 times 2 will get that. So 6 times 2, 5 times 2 is?
10.
Yep. And times 1 to get to 12 times 1 or 5 times 1 is what?
Equals 2.
What are you talking about?
Equals 5.
All right, so now we're going to add. We're going to put our equal line. We're going to add our operation sign. We have both the same denominators. What's our denominator, Jamil?
A 12.
All right, so we're going to put our denominator. And we're going to circle our number sentence. And what's the number sentence?
10 plus 5.
Is how much? You add 10, count 5. 10, you at 10 already.
11, 12, 13, 14, 15.
There we go. So 15 over 12. Is there something wrong with that?
Proper fraction.
There we go. Bling, 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 bling. Good job. So we got the 15 over 12. We need to put that 15 inside our house. 12 and 15, that's very close. We only could get one group, guys. So we're going to put that 1 over top of the 5. We're going to do the multiplication. 1 times 12 is how much?
12.
All right. We're going to put that up underneath the 15. And we're going to set up for our subtraction. We're at 12. We only got to count up to 15. We're at 12. We only got to count up to 15. What's the answer?
13, 14, 15.
So what's the answer?
3 fingers.
There we go. 3. So we put that 3 over 12. But when I even say 3 over 12, I already know I can get a 3 group out of 12. Yes?
Yes.
Okay, so we go in and we divide by 3. We divide by 3. That's going to leave us with 1/4. Why? 1 left from the 3 out of 3. 12 divided by 3 is going to leave us with 4. We have a new fraction now of 1/4. Okay? Yes?
Yes.
And we have a whole number right here. Excuse me. We're going to add that whole number on top of our whole numbers. And now we're just going to add our whole number side. We have 1 plus 1 is
2.
and 2 plus 1.
3.
There we go. So our answer is going to be 3 and 1/4. That is the answer. 3 and 1/4. So for our final problem for today, again, we're still doing the sum and we're still using our diagrams. So for this picture, how many holes do we have?
2.
All right. So that's just going to give us the 2. And then how many fraction pieces?
1, 2, 3, 4, 5, 6, 7.
7 over what?
7 over 12.
There we go. All right. And then how many whole pieces do we have here?
1.
And how many fraction pieces do we have?
1.
All right. That one was easy. Move over. So do you notice something? Can we add? Can we subtract? What can we do?
No, we have to make the denominators the same.
Exactly. So what are we going to change that denominator into?
The 12.
There we go. So we're going to set these to a 12. Why? Because 3 can become 12. We know that. And how can 3 become 12?
3 times 4.
There we go. Times 4. Great job. That's it. Just think multiplication. You know this. You got this. And 1 times 4 is how much?
4.
There we go. And going up to the top. Times 1 kept us at 12. So we times 1 at the 7. And what's the answer?
12.
We did that. 12. Then times 1 at the 7.
7.
There we go. So now we can pull our equal line, add our operation sign, and we can go ahead and get ready to add. We have denominators of what? They're the same now. So what's the denominator?
12.
We're going to set our denominator for our answer at the 12. We're going to go ahead and circle our numerators. We're going to add. We're at 7. We're going to just count up to 4 times?
11.
There we go. Great job. 11. So we got 11 over 12. These are not odd. These are not even. That's an odd. That's an even. There's nothing we can do with that, right? So that fraction side is totally done. Now we just look at our whole number side. 2 plus 1 is how much?
3.
There we go. There's easy peasy. Last one was nice and easy. What's the answer?
3, 11 over 12.
There we go. Great job. 3 and 11 over 12. Awesome job. Awesome job. All right, everyone. So that's the end of our video. I hope you found something useful. And always remember, it's not what you don't know, but what you're willing to learn.